Question number 12. The contingency table below presents a portion of the results of two anti-doping tests performed on male cyclists following a competition. All right, so we have to calculate this, and so I did the 6.25 subtracted from 21.875, and that gave me 15.625. I added these two together to get 25, and then I 75 minus 6.25 to get this number. Oh, I added the 25 and 75 to get 100. Then 75 minus 6.25 is 68.75. Added those two to get this one. Or I could subtract the 21.875 from the 100 to get that one. But either way, 78.125. We've completed the table provided. What is the probability that a randomly selected cyclist has a positive test result on both tests given that he had a positive test result on one of the two tests? So this would be you got a positive on both. This is you got a positive on one. You got a positive on this one, on the presence of growth hormones. You got positive on growth hormones, and it's positive on growth hormones and positive on EPO. And this one is positive on growth hormones and negative on EPO. This would be positive on EPO and negative on the growth hormones. This would be negative, negative. So this is negative on both. The probability that a randomly selected cyclist had a positive result on both tests, given that he had a positive result on one of the two tests. Okay, so we're saying he had positive on both, given that he scored positive on one of the two. He had positive on one and positive on the other, given that he had positive on one or positive on the other. That is this intersect that. So if we had a, let's say this was set A and this was set B, and what does A and B have in common? That. What does this part have in common with A union B, right? Like A union B would be all of this, all right? So we're saying, what does this part have in common with the whole thing? Well, the only thing it has in common is itself, is that part. P1 intersection P2 have in common with P1 union P2 is just P1 intersection P2. Probability of testing positive on both, okay, which is 15.625, okay? The probability of testing positive on one or the other is this one plus that one. So this is the people who tested positive on one, this is the people who tested positive on the other, and this is the people who tested positive on both. So if we're looking at our Venn diagram again, so the people who tested positive on one would be in this region. This would be the people who tested positive on both, and this would be the people who tested positive on the other. So A union the two would be all of that all together. We're saying the 6.25 plus the 9.375 added to the 15.625 is 31.25, or 0.3125 as a decimal. All right, so we divide those, and that gives us 0.5, or 50%, or 1/2. So 1/2 the people, because of the probability that a randomly selected cyclist has a positive result on both tests, given that he had a positive test result on one of the two tests, is 0.5, or 50%, or 1/2. All right, we could also figure this out by saying that the probability of P1 union P2 is equal to the probability of P1 added to the probability of P2, take away the probability of the intersection of P1 and P2. And remember, this is the intersection of P1 and P2. The probability that you tested positive on number one is 25. Okay, the probability that you tested positive on the other one is 21.875, or 0.21875 as a decimal. Take away the intersection, take away 0.15625. And what does that equal? The 0.3125. And that is it for question number 12. Have a good day.